Now let's look at another type of questions that they can ask. Derangement formula. Now what is derangement? Derangement means none of the correct elements goes in its correct position. So generally this type of questions they ask by giving the example of an envelope. What they do is, let's say I have three envelopes, envelope 1, envelope 2 and envelope 3, and I have three letters as well, letter 1, letter 2, letter 3. Now letter 3 is supposed to go into envelope 3, letter 2 is supposed to go into envelope 2, letter 1 is supposed to go into envelope 1. However, as per derangement formula, what happens is none of the letters go into their correct envelopes. That means all envelopes, if I open any envelope, I'm going to receive a wrong letter. That means, let's say it can be 2 goes to 3, 3 goes to 1 and 1 goes to 2. Now there can be different combinations, right, for having wrong arrangements. So the formula and number of ways in which I can have wrong arrangements is this: n factorial 1 minus 1 by 1 factorial, and this goes up till n. What is my n here? N is the number of envelopes or letters that have been provided to me. N is the elements basically. So you can look at this formula as well to solve. Let's look at an example to clear our doubts more. Before that, let's just look at the explanation. The term n factorial accounts for the total number of permutations of n elements. The sum adjusts the count to exclude those permutations where at least one element is in its original position. That means all those permutations are removed where even one element is in its original position. Apart from that, there is an approximation. Let's say if I have n tending to infinity where n is very large, then my dn or my derangement combinations would become n factorial by e. Simply this entire thing we can write it down as e. Now why is it that when it is tending to infinity we are writing it down as e? You will learn it when you study limit, continuity and derivability. There we will be learning a Maclaurin's theorem and Taylor's theorem, where you will see how different functions can be expanded, and similarly e has been expanded in that format, so that is why we can write it down as n factorial by e. Now this works only when n is very large. Had n been small, you can simply calculate it using this formula. Now let's look at this example. Again, a question that was asked in previous year JEE Mains. In an examination, 5 students have been allotted their seats as per their roll numbers. The number of ways in which none of the students sit on the allotted seat. So here, that means we have specific roll numbers for 5 students, and we have to arrange them in such a way such that no student is in their right roll number. So simply we can use our derangement formula, which makes it n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. So let's just solve this. What are we going to get? 1 and 1 would get cancelled out. Here we would have 1 by 2 minus 1 by 6 plus 1 by 24 minus 1 by 120. Here we would have 5 factorial, so this would cancel it out and we would get 44 as our answer. So this is our answer. Of course, simple question, just apply the formula, get the answer. Now there are a few standard results related to geometry that you need to understand. You need to remember these formulas. When you study coordinate geometry such as straight line, ellipse, hyperbola, all those chapters, that time you will get more analysis as to how this entire permutation is happening. Apart from that, for now, you can simply just remember these formulas. Let's say if there is a circle and they have given, and instead of a circle, what they have given us, they have given us that there are, let's say, n number of points which basically form the circumference of a circle. They've given us n points. Now what are the number of straight lines? So it is going to be nc2, because for any straight line we need to have at least 2 points. If we have 2 points, we can find out any straight line that can pass, right? So similarly, for straight line it becomes nc2. For a triangle we need minimum 3 points, so it becomes nc3. For quadrilateral we need minimum 4 points, so it becomes nc4. So keep this formula in mind. There are a few more related to geometry that you need to remember. Again, you will understand the main concept behind this when we study coordinate geometry. Apart from that, Right now you can simply just remember these formulas. Number of total different straight lines formed by joining n points on a plane of which m are collinear. That means there is a plane, let's say xy plane. This is my xy plane, so I can represent it in this way also as axis. XY plane, there are n different points given to me. Now out of which these m number of points are collinear. I hope you understand what is collinear. Collinear means these are points that can lie in a straight line. So these points are collinear. So what would be the total number of straight lines that can be formed? So it would be NC2 minus MC2 plus 1. Again, I hope you all remember this is NC2 minus MC2 plus 1. Do not confuse yourself as to what this bracket is. We had studied in binomial theorem as well as in the previous lectures of PNC as well. Now number of total triangles formed by joining n points of which m are collinear, simply NC3 minus MC3, no plus 1 is here. Number of diagonals in a polygon of n sides, NC2 minus n. If m parallel lines in a plane are intersected by a family of n other parallel lines, then the total number of parallelograms formed are. I hope you all know a parallelogram is formed with two parallel lines this side and two parallel lines this side. That is why we call it a parallelogram, right? So when there are m number of parallel lines and there are n number of parallel lines, both are different and they intersect with each other, how many number of parallelograms would be formed? Simply MC2 into NC2. So keep these formulas in mind. This one stays to be the most important one because there has been a question that was asked based on this formula, number of diagonals in the polygon of n sides. We will look into that question as well. So here it is. If in a regular polygon the number of diagonals, here they have given us the number of diagonals. The formula was to find out the number of diagonals, so we have to find out the number of sides. So it would simply be NC2 minus n, where n is my number of sides. This is equals to 54, simply using this formula. Now let us solve this. We are going to get n into n minus 1 by 2 minus n. This is equals to 54. So from here I can take 2 to the other side. This would become n into n minus 1 minus 2n is equals to 108. From here we can get n square minus n minus 2n, which makes it minus 3n minus 108. This is equals to 0. So from here what do we get? N plus 9 and n minus 12. So from here, of course, n cannot be minus 9. My number of sides of a polygon cannot be negative. So this one is rejected. This one is taken. So my n becomes 12. This is my answer. Simply formula based questions are asked from these geometry formulas. So keep in mind these formulas. Now let's look at this question. Again, a question from the previous formula. If P1, P2, P up till P15 be 15 points on a circle, then the number of distinct triangles formed by Pi, Pj, Pk such that I plus j plus k is not equal to 15. So we have to form the number of triangles in which such that these points summation does not equal to 15. Apart from 15, we have to consider each and every triangle. So first of all, since they have given us I, j, k, and P is, if you look at this number here, this subscript here, it is basically increasing. That means from here what we can say is I would be less than j and j would be less than k. This is one thing that we can find it out. And I plus j plus k should not be equal to 15. This is the other equation. Now first of all, let us find out the total number of triangles that can be formed from these 15 points. From there, we will subtract all those triangles whose points sum become 15. We will get our answer. So first let us find out total triangles. Total number of triangles. As we had studied in the previous formula, it would be NC3. Our n is 15, C3. So we found out our total number of triangles. Now let's find out the triangles in which, now let us find out triangles in which I plus j plus k is equals to 15. Keeping in mind this condition where I is less than j is less than k. So from here, what do we get? Let's say if I suppose I to be 1, that means my j plus k should be equal to 14. What are the possible cases here? Either j can be, what are the possible cases of j comma k? It can be 2 comma 12, it can be 3, 11, it can be 4, 10, it can be 5, 9, it can be 6, 8, it can be 7, 7. Again, I cannot take 7, 7 because j is less than k, it is not equal to k. Of course, the 15 points that I have all are different points. There is no coinciding point here. That means I cannot take 7, 7. So from here, how many cases are we getting? 1, 2, 3, 4 and 5. So we have 5 cases here. Now let's say if my I is equals to 2, then my j plus k would be equal to 13. Now let us again start with the same thing and find out how many are possible. There can be 2, again I cannot take 2 j as 2, because if I take j as 2 it would be equal to I. However, I have to keep my j greater than I, so I have to start with 3. So 3, 10 is one possibility, 4, 9 is one possibility, 5, 8 is one possibility, and 6, 7 is one possibility. So we get 4 possibilities from here. Now similarly, let's do it for I is equals to 3. My j plus k would become 12. Now my j would start from 4. I would have to take 8 here, 5, 7. Again, I cannot take 6, 6. So I have 2 possibilities from here. Now what if my I is equals to 4? My j plus k would become 11. Now what are the possibilities I can have? 5, 6. That's it. Apart from that, I cannot have any other possibility. If I take I as 5, I will have to take j as 6. And if I and j are 6, they make it total 11. So my k cannot be 4. K is the greatest number here. So these are the total possible ways in which I plus j plus k is equals to 15. So what would our answer be? As they had asked us the number of triangles formed by points in which I plus j plus k is not equal to 15. So our answer would become 15C3 total triangles minus the number of triangles that are formed with I plus j plus k is equals to 15. What are they? 5, 4, 9, 9 plus 11, which is 12. Upon solving this, what do we get? 15 into 14 into 13 by 3 into 2, 3 5s are, 2 7s are, minus 12. And from here we get our answer to be 443. So this is how you solve questions based on geometry. Again, if you had remembered the formula that total number of triangles is 15C3, your question would have been pretty easier. And the another catch that was given in the question was that for you to identify I is less than j is less than k. Now let's look at this final topic. Let n is equals to p1 to the power alpha 1, p2 to the power alpha 2, where p1, p2, p3 are prime numbers and alpha 1 are their exponents, natural numbers. Then the total number of divisors of n, including 1 and n. I hope you all know what divisor is, a number which can divide n. So that would be this. The total number of divisors of n, excluding 1 and n, would be this, minus 2 from here. Of course, we are not including 1 and n here, so there would be a minus 2 here. The total excluding 1 or n, any one of them. That is why we are subtracting 1 here. Now let me take an example and show it to you. Let's say if my n is 100 here. So how can I write my 100 as? This can be written as 2 to the power x into 5 to the power y. Sorry. Of course, these two are prime numbers. There is no 3 or 4 in this. So this can be written as 2 to the power 2, 5 to the power 2. Now, how can you find out these exponents? These exponents can be found out using our formula that we studied. If there is a direct number that has been given to you, for example, 100, you can simply find it out by hit and trial. If let's say a factorial had been given, then you would have to use the exponent of p in n factorial formula. From there, you could have found out this formula. From here, we've gotten our p1, p2. Our p1 is 2, my p2 is 5. And what is my alpha 1? Alpha 1 is 2, alpha 2 is also 2. So based on these values, we can find out all these 3 values. So remember these formulas as well. It can come handy while solving questions. So that was all, mostly about the theory and different concepts and different ways of finding out permutations and combinations in this chapter. Again, as I mentioned, this is a fairly easy chapter. There isn't much formulas for you to remember or any different things that you can remember. The only thing that is required here is for you to think and solve your question with common sense. Now we'll be looking into a few previous year JEE Mains questions. Of course, we are going to be looking only at a few questions. Mainly all the questions that we did while learning the theory as well, all those questions were also from previous year JEE Mains. So you get the idea as to what level of questions are asked from this chapter. They are pretty simple.